Everyone, and welcome to my channel. My name is RF, and today we're going to solve some harder Thevenin and Norton equivalent problems. So if you haven't yet subscribed to my channel, please do subscribe, and if you like the content that I provided, please just hit the like button at the below of this video. Thank you. Let's get started. So let's try and find a solution for this one. So in this circuit, as you can see, we have independent sources and dependent sources. And what we're going to do is to try to find the Thevenin voltage and Thevenin resistor seen from port A, B. So the Thevenin voltage and resistor seen from port A, B. So the difference of this circuit with the other ones that we used to solve in previous sessions is that in this circuit we have both independent and dependent sources. So this 4ix is a dependent source and this 25 volt is an independent source. So the same method applies here as well to find the Thevenin voltage and Thevenin resistor, which is to turn off all the independent sources and try to find the Thevenin resistor. But what should we do with the dependent sources, with this 4ix? I'm gonna just try to solve it step by step. So let's start with the general concept to find R Thevenin. So to find the Thevenin resistor, we turn off all independent sources and try to find the equivalent resistor seen from port A, B. Okay, that's what we're trying to do. So if I turn off the independent source, which is this 25 volt, this independent source becomes a short circuit. So step 1, I'm going to try Thevenin resistor. So I still have this dependent source, which is 4ix. Oh, yeah, and that goes to a 20 ohms resistor. And here, there used to be an independent source which turns to a short circuit because I'm turning it off to find the resistor, the equivalent resistor, which is my Thevenin resistor. And then here I have a 40 ohm, and here I have 75 ohms. And over here is my port A and B, okay? Which I'm trying to find the Thevenin resistor seen from these ports. So 40 ohms, 75 ohms. All right, it's a little messy here. It's negative and positive. And this 4ix is in relationship with this ix flows into 75 ohms. The method that we should use in such circuits is test circuit, or I can define it as test source. What is a test source? Let's say that I want to substitute all these circuits here. That's actually the concept of Thevenin circuit. So I'm going to just substitute all these elements with an independent source. I'm going to call it the Thevenin voltage, and a resistor, which I'm going to call it Thevenin resistor. And then here is my port A, B. If we consider this resistor the Thevenin resistor, and I don't know the value, so the value is unknown. How else I can find an unknown resistor, let's say in a lab? If I give you a resistor which the value is unknown, how would you find the value of this resistor? If you are able to connect this resistor to a current source, let's say the 1 amp current. As you know, we have those power sources in the labs that you can set the current, and also we have the meters in the lab, so there are two probes that you can connect to the heads and tails of resistors and read the value of voltage. So if I read the value of the voltage across this resistor and then divide it by this current, which is 1 amp, so that's actually from Ohm's law. I know that the voltage divided by current is nothing but the resistor. So this voltage is actually the same voltage across the Thevenin resistor, so I'm going to call it just a test voltage divided by 1, but whatever is the value of this voltage, it helps me to find the Thevenin resistor. So I'm going to apply this method to this circuit now in order to find my Thevenin resistor. So that's what we call test source. So I consider this circuit. I try to draw it a little cleaner this time. Positive, negative, 4 times Ix. And I have 20 ohms here, 75 ohms, and then I have 40 ohms here. And over here, I'm going to do the same. There used to be a resistor here, which I called it Thevenin resistor, but now I don't know the value of this resistor. I'm going to just use a very common method known as test method. So I connect a 1 amp current source. This is the same port A and B. So I connect it to a test source with the value of 1 amp, and I try to find the voltage across my current source. I'm going to call it just V test. Alright, so what I have done is that I connected this test source to my circuit, and I'm trying to find the voltage across my test source in order to find the Thevenin resistor. So the Thevenin resistor in this case becomes the V of test over 1. So what I need to find is V of test. What is the value of V of test now? Let's try to find it. Have a look at this circuit now. How can I find the V of test? If I consider the bottom of my circuit as the reference voltage, and you know better than me, reference voltage means the voltage of this point is 0. So the test voltage is over here. Yeah, that's the test voltage. Okay? Can I say that this voltage is the same voltage at this node and the same voltage at this node? So all these parts are the test voltage. I'm going to call it VA for now. And I can see there's like a node, a very big fat node here that I can consider currents flowing out of this node going to 75 and 40 ohm and this 20 ohm resistors, and this 1 amp current flows into the node. So if I call the node node A and I try to find KCL at node A, let's try to find it. The KCL at node A. So you know, for all currents, we consider the voltage of the starting point minus the voltage of the ending point divided by the resistor. So for this current, I'm going to call it I1, and let's call this one I2, and this one I3, and this one is just 1 amp that flows into this node and then peels off into I3, I2, and I1. So what is I1? So the voltage of the starting point, which is VA, minus the voltage of ending point, it ends in 4Ix, and divided by the resistor. What's the resistor that I1 flows into? It's 20 ohms, right? Plus, same method, this time for 75 ohms. So that becomes VA minus, this is the ending point of I2. So what's the voltage here? That's our reference voltage. Yes, it's 0. So minus 0 divided by 75. What else? Yeah, we have this branch here, which is VA minus 0 divided by 40 equals 1. So I have Ix and VA. So this is one equation and two unknowns. Is it possible to solve? No. What I need is one equation and one unknown. How can I find one of them in relation to the other? So I have to find a relationship between VA and Ix. If we look at this branch here, I2, let me just show you, just in case you have forgotten. I2 is nothing but Ix over here. So I have Ix flowing into 75 ohms. So this branch, this middle branch, is actually my Ix. Okay, so I can say that VA over 75 equals Ix, or VA equals 75 times Ix. Okay, that's much better now. Let's call this equation equation 2, and let's call this equation equation 1. And I'm gonna just put equation 2 into equation 1. So gonna just substitute 2 for 1. Then I have VA minus 4Ix divided by 20 plus VA over 75, which is Ix, plus VA divided by 40 equals 1. And then instead of VA, I'm going to put 75 Ix. So 75 minus 4, let's just make it simpler, 71 Ix divided by 20 plus Ix plus, again, VA, which is 75 over 40 this time, Ix equals 1. If I find Ix from here, then I can find VA, then I can find Vtest, which is nothing but the same as VA. So I'm gonna just multiply both equation sides by 40 in order to just make it simpler. So 40 and 20 cancel out, and this value will be multiplied by 2, will become 142 times Ix plus 40 Ix plus 75 times Ix equals 40. So let's just do some math here to figure out the value of Ix. I've done it very quickly here, so that becomes 257 times Ix equals 40, and from there Ix equals 0.16 amps. Can I calculate VA now? Yes, VA was 75 times IX. That means 75 times 0.16, and that becomes 75 times 0.16, yeah, almost 12. I shouldn't have said 12 ohms, it's actually 12 volts. But since we know that R Thevenin is the same as V test, then I can say that my R Thevenin is also 12, but the unit is in ohms. So the Thevenin resistor is 12 ohms. Continue on our problem. We now try to find Thevenin voltage. In order to find Thevenin voltage, we know that Thevenin voltage is the voltage of OC, or open circuit. So the open circuit voltage is actually voltage of this point over here, because over here I have open circuit, so no current flows into this part, so the circuit ends here. Okay, I can just cut these points, and I can call this point as point A and this point as point B, because this is all wire, and wires are the same potential, right? So I can say that this potential will be transferred to here, and this potential will be transferred to here. Now, what I need to find is the voltage of this point over here. If we look at this circuit, I have nothing but voltage source. So I'm just going to write it down, just voltage source. When I have just voltage sources, that gives me a very green signal to try and solve the problem through KVL. What if I had a current source? Yeah, the answer is no, because if I know the current, then I cannot use KVL. But in this circuit, I have nothing but voltage sources. I know this one is a dependent source, which we're going to figure out how to address it in our solution. So I consider two currents. Let's call this I1, and this current in the middle loop as I2. And what about this current? Yeah, there is no current. It's zero, because it's open circuit. Okay, so let's try to find KVL at loop 1. So I have I1, so I start from this point and I start moving. I see minus 4 times Ix, or I can say 4 times Ix is my voltage source. So I'm going to just keep it at the left side of the equation, because this is definitely my source. So all sources can be put in one side, and all the resistors, or in other words, all the impedances that we're going to find out later, the concept of impedance, can be written in the right side of the equation. 4 times Ix equals 20 times I1 plus 75 times Ix. Instead of Ix, I'm going to write I1 minus I2. So if you consider I1 flowing into this node here, I2 peels off and Ix goes down. So Ix is nothing but I1 minus I2. So I'm going to just write everything based off I1 minus I2. Yeah, we can immediately figure out that Ix is actually I1 minus I2. So can I just make it a little more beautiful? Yes. 4 times Ix is 4 times I1 minus 4 times I2 equals 20 times I1 plus 75 times I1 minus 75 times I2. So let's consider all I1 in one side. So 20 plus 75 is 95. 95 times I1 minus 4I1 is 91 times I1. And then I have minus 75, and then plus 4, that becomes minus 71 times I2 equals 0. So I'm going to just circle this and just put it aside for now. This is one equation that can help me solve my problem. Now let's write KVL at loop 2. So this is my loop 2. If I move from this point onward, I have minus Ix. So I'm going to consider it as minus Ix times 75 ohms. So I'm going to say 75, and instead of Ix, I'm going to write I1 minus I2. And then I have plus 25, and then I have plus 40 times I2 equals 0. Yeah, that's good. I have everything based off I1 and I2. That becomes minus 75 times I1 plus 75 times I2 plus 40 times I2 equals negative 25. So I can say minus 75 I1 and then I have 75 plus 40, that becomes 115 times I2 equals minus 25. So I have two equations and two unknowns. Can I solve it? Yes. So let's try to find I1 and I2 from these equations. There are a couple of methods that I'm pretty much sure you guys know better than me. So we can use calculators, or even we can manually try to solve it and find the values for I1 and I2 from here. So I just used a Sharp calculator. So just very quickly, I'm going to let you know, if you use Sharp calculator, you press mode and then you enter your equation mode. So you press mode, then you press 2 to select the equation, and you select two variable linear equations, and from there you input all the equations coefficients. So in Sharp calculator, how it works is that it considers this coefficient as A1 and this one as B1 and this one as C1. And then in second equation, you will continue with A2, B2, and C2. And then it gives you X and Y. So for sure, X is your first unknown and Y is your second unknown. So based off what I have here, my X, which is I1, is minus 0.35 amps, and the Y value, which is my I2, is minus 0.44 amps. So these are the values that I have calculated from my calculator. And now let's go back and try to find the V of OC over here. So I can see V of OC, which is here, the voltage of AB, is I2 times 40. Am I right? I hope that you guys also approve it. So 40 times I2. So let's go back here. So I2 is minus 0.44. So 40 times I2, which is my VOC, which is my Thevenin voltage. So 40 times I2, let me just that becomes almost, so the value actually becomes 17.6 volt, but with a negative sign, because the current is negative 0.44, so it will become negative 17.6 volt. So that's my Thevenin voltage, which is the same as my open circuit voltage. So thank you very much for your time. I hope that you guys have solved it by yourself, and I hope that we have reached to the same values. Please let me know if you see any anomalies or you have found the different values. Let me know, and thank you very much for your time. And let's share the contents with your friends and try to help everyone know all these contents. So please do subscribe and like my channel if you like the contents I provided. Thank you very much. Have a good day, everyone.